Capitalized Math Industry, and we are going to take a look at the reaction time. So this is going to be a physics video explaining how to understand how fast something reacts to do some kind of action. So when you think of reaction, what do you think of? Well, it's usually someone or something completing a task in a short period of time. Sometimes you need to complete tasks when they're right away or out of nowhere. Like if you were ever playing those click games in class where they would test your reaction time by pressing a button on the keypad, or if you have like a test where you have to click as many buttons as you can in a certain amount of time, that's our reaction. But what we're going to understand is find how long the reaction time is. Oh, and yeah, we've also learned about this formula, final velocity, this formula, the displacement, and this formula, the velocity squared. So what we're going to do is do a little science experiment. So you see this ruler over here? What we're going to do is measure how many distances in centimeters that someone reacts. So what's going to happen is, this requires two people to do. One person holds the ruler like this, and the other person is ready to catch the ruler. Once the ruler drops, like that, the other person will have to try and catch it. So, when they understand what the distance is, this meter stick doesn't really have any centimeters, but try to find a yardstick or a meter stick that uses centimeters. So that centimeters is going to tell you how fast the person reacted and what the displacement is. So let's solve one of the problems. Try the experiment on your own and type in the comments what you got, what your reaction time was, and how many centimeters you got.
Start! Finish! Start! Finish!
Imagine you and your friend were doing this physics lab on the meter stick, and someone has put their finger on 10 centimeters. This meter stick doesn't have centimeters, so we're just going to see what happens. So what we're going to do is find out what is the time, and how many seconds was the reaction of your friend. So over here, we have like a speed dating problem right here. We have initial velocity, final velocity, your displacement, acceleration, and your time. We already understand that what we're trying to do is find out what your time is, which we have no clue of. But however, we do understand that your friend has stopped their thumb at 10 centimeters. The gravity, or the gravitational pull, is going to be minus 9.8 meters per second squared. And that represents the Earth's gravitational pull. And negative because it's falling. We also understand that VI is going to equal 0 meters per second. Because at the start of the science experiment, someone or something has to be holding the ruler until it falls, which is technically the rules of the game. We have no idea what your final velocity is, so we have no clue on what that is. So what we have to do is find out what t is. So we have 3 of those problems that we showed in the beginning of this video. Final velocity, we have your displacement, and your final velocity squared. Well, what we're going to do is try to make some kind of new formula so we can immediately get to time and see what we can get by calculating on a calculator. We could use this one, but that brings us to the final velocity, which we don't really want. This one, however, over here, yes, there is a t squared right here, and it is your displacement is going to be your initial, multiply that by your time, then we have to add by 1/2 the acceleration times t squared. But hang on, what if I told you that there is a way to get t alone and solve it right away? We must understand that your displacement is going to be 10 centimeters. But hang on, this is where everything gets confusing, because many students get these incorrect on their test because on the acceleration it says negative 9.8 meters per second squared. The issue about that is if we're measuring the displacement in 10 centimeters, that's not going to align with meters per second squared. So what we have to do is kind of change it. So the 10 centimeters is going to have to transition to just meters because of meters per second squared. So 10 centimeters in meters is 0.1 meters. And that is because we have to divide that by 100. That is all part of the metric system, which will be in another video. So now we have everything in meters. No more 10 centimeters. Now it's just 0.1 meters. So what we have to do is put it right here. 0.1 meters. We still haven't figured out what your time is, but there is a little problem about this formula, or this kind of formula. So the whole idea is to get t alone and quickly get to your time. So we have a t squared, and some other variables right there. That does remind me of something. It reminds me of the quadratic formula, and their formulas like ax squared plus bx plus c equals 0. We could use a quadratic formula, but in some other of our math videos, we explained that teachers actually discourage the quadratic formula. That's because there's room for a lot of mistakes since there's a lot of steps. And also, it can only solve algebra equations that have an x squared in it, which is going to be very, very complicated when you do like x to the 4th power or x to the 3rd power. So let's get that t, yes, that t alone. We start out with this formula. What we have to do is do literal equations. So our first plan is when you have an initial velocity of 0, that tells you that anything multiplied by 0 is going to represent 0. Assuming the time is like 2 seconds, 2 times 0 is 0. So we can get that out of the equation. Now our formula becomes d equals 1/2 of your acceleration. Then we have to square that t as time. Let's get rid of that fraction by multiplying both sides by 2. This gets rid of this fraction, and this gets rid of that right here. But that 2 multiplies into your d, or displacement. Your formula is now 2d is going to equal your a t squared. We still haven't gotten that t alone. So what we have to do is divide both sides by a. So now your formula becomes 2d divided that by a is going to equal your t squared. T is isolated, but the issue is there is a square right there. T wants to be totally independent from that square. So to find the square and find the t, we have to square root the square. Square root all this and square root all that stuff. Your final equation, or your final equation is going to be t is going to equal the square root of 2 multiplied by your displacement, divide everything by your acceleration. In more college terms or in more standard versions, you'll see like t is gonna equal the square root of 2 times h, divide that by g. But technically, they're the same thing. Right here, this one is gonna be a lot more simpler because it explains the mathematics behind it. And since we have found this formula, we are allowed to use it and plug our literal information in here. As long as you show your work on how to get to that formula and how you got to that answer, your physics teacher is going to be happy about that and also allows you to do that and gives you full credit on your exam or your question on your test. So by using the formula, we can definitely power it up. So the formula is right here. What is t? Let's quickly solve it with reaction time. So we have t is going to equal square root of 2 times d divided by a. So t is going to be the square root of 2 multiplied. Our d represents 0.1 meters, since we have to measure that for the acceleration too. So 0.1, then we have to divide everything by negative 9.8. But when you say 0.1 meters, you're going to turn it into a negative 0.1 meters because this so-called ruler is going to fall and collapse. So that's why you have a negative displacement, because the rule is falling to the earth. And when you do this times that, divide by that, and square root, you'll get your t. So when you use a calculator, you are going to get the answer when you do 2 times 0.1, negative 0.1, divided by negative 9.8. That will bring you to this. But when you square root that, your answer will be 0.141 seconds. And that is going to represent your time on how much time your friend reacted when he grips onto the ruler at 10 centimeters or 0.1 meters. So that explains the reaction time, and that also explains this brand new formula. This new formula right here is not going to be included with this. Also, we're not going to have it included in this, and also that. What we can do is use one of the formulas to prove we can bring it to this. Then the teacher allows us to use that. Then we get to our final answer. I hope this video has helped you understand the reaction time. Thank you for watching Taoping Life's Math Industry, and thank you for reacting to this video. Tell in the comments below on how you reacted to this video.